Hey guys, welcome back, and today we're going to be talking about transforming the coordinate space of your graphing region, which is a very advanced topic. This comes out of multivariable calculus, so if you're not taking a multivariable or vector calculus, you probably don't care too much about this, but either way, we're going to be transforming our coordinate space. This is a pretty simple task to do. All you really have to do is right-click, go down to UV transformations, and then from there it's pretty easy. But first I figured we should probably look up some sort of an example problem online. So I googled and found this. It says to find T of S when T of UV is equal to UV and u squared minus v squared. And to find the shape of the unit square, that's a square with a dimension of 1 by 1 on the UV plane. So what I'm going to do first actually is first graph the square that we have, and then after that transform that using our UV transformation. So going over here to make a square, I know that x needs to equal 0, x needs to equal 1, y needs to equal 0, and y needs to equal 1. Then also, because we want to just have the square and not all these other blue lines hanging around, I'm going to say that x is from 0 to 1, and all of these are going to be from 0 to 1. Whoops. From 0 to 1 and from 0 to 1. So now we have this square hanging out in the coordinate plane, and we need to apply the UV transformations to the whole coordinate system. Well, originally we had UV and u squared minus v squared. So right-clicking here, going to UV transformations, instead of just having u, because that's a non-transformed axis, then we would have u times v, and then for the v, which is the y, then we need it to be u squared minus v squared. As soon as we do that, it's going to graph it again, and as you can see, we've got a transformed coordinate space. So these are the four functions of the sides of the square being transformed onto that space. So not very difficult, pretty simple to do. Really saves a lot of work. I actually, to be honest, I have yet to find any software, whether it's in the web browser or something that you can download that actually does this. I'm sure there's something out there that does, but this does it, and it does it really easily, to be honest. So pretty valuable there. And also, if you noticed, there is a it's actually technically a UVW transformation. There is a third dimensional transformation. So now that we're talking about it, we might as well do something with that. So I'm going to clear this out, and we're going to graph something in 3 space. Let's just do z equals, let's do simple, z equals x. So z equals x, oh, that's already transformed. So z equals x is normally just a plane. However, we are operating under a transformed UV space, which means we now have something that is very different than just a regular plane. So this is a transformed, wow, I've never seen that before, but either way. So we could also transform w. We could like make w just be, I don't know, sine of w or sine of w minus v, or let's just do that, sine of w, and that gets us, hello? Oh, there we go. Okay, so that gets us that. We can see that w is, or the z-axis is varying based on the sine of itself. So if I zoom inward just on the vertical scale, then you can see what's going on. That's kind of cool. That's really sweet. I've never seen that before. Okay, so there's that. Standard UV transformations. Again, just to reset everything would be U, V, and W. I don't know why it keeps putting that. There we go. It's probably a small bug, but I don't really care too much. So either way, so there it is. Regraph, and we've got this regular plane going on here. So that's an untransformed plane, something you would expect to see, but the other one was transformed, just did it in the reverse order. So there it is. So 2-dimensional UV transform, 3-dimensional UVW transform. This is where you can get this calculator to graph things under spherical coordinates. You just have to look up what those coordinate transformations are and then apply the appropriate UVW transformations, and you can get it to work. So either way, hope you guys are having a good day. If you have any questions, let me know, and I'll see you next time.